Welcome back. The American University in Cairo is organizing a public lecture on a new discovery that was announced by NASA last week. The discovery unveils a new form of life that opens up a host of possibilities to find life in our universe. With us this morning to talk about this discovery, its implications, and the future of life on Earth and beyond are Dr. Ala Ibrahim, Assistant Professor of Space Astrophysics at the American University in Cairo. Dr. Ala, thank you so much for being with us.
Pleasure to be here.
And of course, former NASA scientist, of course, Mr. Mike Nassar, an entrepreneur and CEO of a sustainable development company. Mr. Nassar, thank you for being with us.
It's a pleasure to be here with you.
Mr. Nassar, we are hearing more and more about the challenges to life on Earth. For example, we have the climate change, the sea level rise, the shortage of fresh water resources, increased energy demands. So, which ones will impact Egypt and the region the most?
Well, you're absolutely right. It is a challenge. Food supply and water scarcity, it is a global problem right now, but mainly in Egypt with its ever-growing population, of course. We're talking about today in Egypt, we're 80 million. We're expecting in 2020 the population to increase to 96 million. And by 2050, we are looking at 118 million. Therefore, water, which is the River Nile, of course, which is shared by eight other countries. So the River Nile, by 2040, we will be needing approximately 105 billion cubic for Egypt alone, which is the entire flow of the River Nile. Therefore, we have to look at alternative sources to generate food, to generate biofuels, to generate employment, basically, in Egypt. These challenges, there is an answer to that, but we need to start now. The answer to that is obviously try to use and utilize the 95% space of Egypt, which is uninhabited, not used for thousands and thousands of years. Technology today has enabled us to actually grow crops, agriculture, and aquaculture, mainly fish and shrimp, utilizing untreated seawater. And I mean by that is it is not desalinated, it is not fresh water, untreated seawater, desert land, and labor. That's what we need.
It will cost a hell of money.
It does cost money, but it is not if you are looking at the type of agriculture. Like if you're growing halophytes, salicornia, and mangrove, which is, by the way, these are indigenous plants to Egypt. If you're looking at the products from seafood, fish and shrimp as well, and the production of biofuels. Salicornia is very rich in oil and protein, and you can extract biodiesel and biojet. The economic model allows such capital investment. It is profitable.
Okay. Start talking about this. How sustainable development is attempting to evade or alleviate these challenges that we were talking about in the beginning, and what are the approaches?
The approaches in terms of finding other ways of utilizing basically the natural resources that we have here. The world today, it's almost 97.5% is water, seawater. We have a lot of desert lands, and in this case, obviously, we need to find a way to do it. So there has been researches going on for the past 30 years, at least with the organizations that we are partners with. We have a partnership with with scientists, and actually Dr. Nina Fedorov, who is the president-elect of the American Association for the Advancement of Science, was visiting here Egypt, and she's one of the biggest supporters of such projects. We have other research institutions in the best universities in the United States, and foundations, non-profit foundations, that are partners with us. So we, for example, from our side, we have utilized and we are partners with the largest research institutions that, and based on a successful track record, proven experience in Eritrea and in Mexico, for example. But we would like to develop this here in Egypt in order to benefit, as I said, from the 95% of otherwise desert land in Egypt. By doing that, you're producing elements that I just mentioned a while ago that are useful for Egypt, for mankind.
So did we start working on these ideas or approaches here in Egypt?
We have started now. We have been collaborating with a number of ministries and government organizations, research institutes like the ARC, which was established in 1911 here in Egypt, a highly qualified organization, and we are approaching right now we have approached the government in order to lease desert land that on an agriculture development lease. And we are on our way. We've been working for 18 months now. So there's a lot of work that has been done. We've selected the site already.
But agriculture is going to use more water, I believe?
No, seawater. Untreated seawater. We don't use fresh water at all. We don't desalinate the water. And we make sure that this is not in areas where there is any aquifers whatsoever. Despite the fact that seawater will not affect in that sense, but we're far away from aquifers anyway. In this case, then, we are utilizing seawater that is not used and is abundant here. You know, Egypt has 3,000 kilometers of coastal lines and desert land. So no, we're not using any of the water that is used for other irrigation. You see, in seawater and what we call the ISIS, which is the integrated agriculture systems, it's a closed loop that utilizes seawater. Effluents are kept inside, so from the fish and shrimp, so from the aquaculture, as fertilizer for the agriculture. And in this case, then, it doesn't go back to the sea. It's fully integrated. So we don't need to use any fresh water at all.